paused to ponder the creation of the shiny gold ring on your finger? Imagine if I were to inform you that it all started millions of years in the past, far below the Earth's surface, within a turbulent environment of extreme heat and pressure. However, how does the raw, ancient material transform into the pure gold present in modern use? The solution can be found in a set of processes that have developed over thousands of years. Stay tuned as we explore the secret process of creating 99% pure gold bars. The origin of gold. How gold forms in the earth. There was a period in history when the planet was a blazing, disordered sphere, consistently bombarded by meteorites. At this time, gold was created. It was created deep within the Earth's crust as a result of a sequence of intricate geological processes. Gold is unique compared to other metals because it is found scattered in different types of rock and sediment, rather than concentrated in veins. So what does it take to create a gold deposit? Creating gold deposits is not a piece of cake, as it needs very specific conditions. It includes high pressure and temperature. Deep within the Earth's mantle, the pressure and temperature create an environment where minerals can combine and gold is formed. Additionally, hydrothermal fluids, rich in minerals, move through cracks and faults in the Earth's crust. These fluids often carry dissolved gold, depositing it as they cool. Furthermore, when these mineral-rich fluids interact with certain rocks, chemical reactions occur that cause gold to precipitate out of the solution and form deposits. These geological processes take millions of years and multiple tectonic events to create concentrated zones where mining becomes feasible. Let's talk about places known for the abundance of gold. From ancient legends to modern economic boons, some regions have become synonymous with gold. These places have a certain percentage of gold deposits. Known for the richest gold fields ever discovered,
we are ready to set up the shaker table and recover some gold.
Is the Witwatersrand Basin in South Africa. This basin has produced over 40% of all the gold ever mined. Following closely is Kalgoorlie in Australia. It is home to the Super Pit, one of the world's largest open-pit mines. It has been a significant source of gold since the late 1800s. The Yukon Territory in Canada, otherwise known as the Klondike Gold Rush, put Canada on the map in the 1890s. It attracted thousands of prospectors hoping to strike it rich. Now to another gold rush in 1849, the famous California Gold Rush. This resulted in rapid population growth and economic development in the now iconic region. This honorable mention won't be complete if we leave out Siberia in Russia, known for vast reserves of untapped gold. Siberia represents one of the frontiers for significant gold mining operations. Discovery and history of gold mining. Human fascination with gold isn't just a modern-day affair. It dates back millennia. Imagine ancient civilizations, long before the advent of sophisticated tools, discovering shiny nuggets in riverbeds. These early humans didn't need a manual. The allure of gold was enough to drive them to their knees, sifting through gravel for those precious specks. The extraction of gold systematically began with ancient civilizations like the Egyptians. Around 2600 BC, they developed rudimentary mining techniques, using slaves and prisoners to dig into riverbeds and mine shafts. Their obsession with gold wasn't merely superficial, it was deeply religious. Egyptians believed that gold was the flesh of gods, making it an integral part of their burial practices. This belief is rooted in their cultural history, which heavily influenced their mining practices. Fast forward to ancient Rome, where gold mining became more methodical. Romans employed large-scale hydraulic mining techniques.
Get a little gold in the box, and maybe we can prove that it all isn't all just a dream.
Diverting water through sluices to wash away soil and expose gold-bearing gravel. The landscape of gold mining changed dramatically with the advent of gold rushes. The California Gold Rush of 1848 to 1855 is perhaps the most iconic. With the discovery at Sutter's Mill, thousands flocked westward in search of fortune, transforming California from a sparsely populated region into an economic powerhouse almost overnight. not just confined to America. Australia experienced its boom with the Victorian gold rush in the 1850s. This period saw Melbourne become one of the wealthiest cities globally, attracting immigrants from far and wide. These rushes had profound impacts on societies, accelerating settlement patterns, fostering infrastructure development, and often leading to conflicts over land and resources. Gold has always held intrinsic value across various cultures. The Egyptians used it for jewelry, religious artifacts, and funerary items. The Mesopotamians crafted intricate jewelry and statuettes, and the Chinese incorporated gold into their currency system early on. Generally, gold played a pivotal role in trade and commerce. Ancient kingdoms like Lydia even minted the first gold coins around 600 BC, revolutionizing economies by introducing standardized currency. Now, on to modern-day mining. The evolution from panning in riverbeds to employing advanced technologies marks modern-day gold mining. For us to look into modern-day gold mining, we will have to talk about the three primary methods. These methods include placer mining, hard rock mining, and byproduct mining. Placer mining taps into the natural erosion processes that wash gold out from its original mineral deposits, often found in the riverbeds or stream beds. This method has a long history, dating back to ancient Egypt and Rome. Placer mining is highly effective for small-scale operations or as a supplementary method in larger mining endeavors. Another method is hard rock mining, also known as lode mining. This involves extracting gold encased in rock formations with tools like excavators, jackhammers, and explosives. This method is labor-intensive, but offers access to substantial gold reserves once the ore is processed.
In these cracks is the gold. It's this black spot here.
While byproduct mining is an intriguing twist on traditional methods, it extracts gold as a secondary product while other metals are being mined. This method provides an economically viable way to extract gold from mines primarily targeting other metals. Each of these methods is utilized based on specific geological settings and the nature of the gold deposit. Extracting gold ore. The journey of gold from the depths of the earth to your jewelry box or investment portfolio is nothing short of an adventure. The extraction process of gold ore is a marvel of modern engineering, requiring precision, power, and a bit of pyrotechnics. Extracting gold ore begins with locating a viable deposit. This often involves extensive surveying and geological analysis to pinpoint where the most fruitful veins lie hidden. Once identified, the real work begins. Picture this: massive drills boring into the earth, their bits working tirelessly to create access points for miners. These drills are not your garden variety tools. They are colossal machines capable of penetrating through solid rock. Drilling serves as the initial step in creating tunnels and shafts that will pave the way for miners to reach deeper deposits. It's an arduous task requiring both skill and patience, as precision is paramount. One wrong move could compromise an entire operation.
This is an impressive operation you got here.
Thanks.
You guys have spent a lot of time and work down here, let me tell you.
After drilling comes the use of explosives. If you've ever wanted to see controlled chaos, this is it. Small charges are strategically placed within drilled holes to fracture large sections of rock, making it easier to remove substantial amounts quickly. This method is not only efficient, but also helps break up ore into manageable pieces that can be transported for further processing. The sight of a controlled explosion in a mine is something akin to a well-choreographed ballet. Each charge goes off in a sequence designed to maximize rock breakage while minimizing risk. However, this part of the process isn't without its hazards. Once the dust settles from these explosive displays, heavy machinery moves in. Think bulldozers, excavators, and haul trucks, all working in unison like a well-oiled machine, pun intended. These mechanical heavy-duty machines scoop up broken ore and transport it to processing facilities. Haul trucks, for instance, are often large enough to dwarf buildings and carry tons of material in one go. Despite all this impressive technology and technique, mining isn't just about brute force. It's also about responsibility. Environmental concerns loom large over any mining operation. Disturbing vast tracts of land can have significant ecological impacts. Think deforestation, soil erosion, and habitat destruction. Miners must adhere to stringent regulations designed to mitigate such damage, such as ensuring local water sources remain uncontaminated by mining activities. They also must be committed to restoring areas post-extraction. Additional measures for dust control must be implemented using methods like water sprays to keep particulate matter from polluting the air. Safety is another critical concern that cannot be overstressed. Mining environments are fraught with potential dangers, from cave-ins and equipment malfunctions to exposure to hazardous substances. Rigorous safety protocols are essential. Crushing and grinding. Gold's journey from ore to shiny bullion involves a crucial stage known as crushing and grinding. This is where the raw, unyielding ore gets broken down into manageable pieces. Imagine trying to extract the essence of a walnut without cracking its shell. Impossible, right? Similarly, gold extraction demands that the ore be crushed and ground to reveal its hidden treasures. Large chunks of rock must be reduced to smaller fragments to facilitate gold extraction. Miners employ various machinery for this purpose, each designed to handle different types of rock hardness and sizes. Jaw crushers are typically used for primary crushing. Jaw crushers operate by applying compressive force on the ore between two plates, one stationary and one moving. This action breaks down large rocks into smaller pieces, making them easier to manage in subsequent stages. Another option for primary crushing is gyratory crushers. These crushers utilize a gyrating spindle to crush the ore against a fixed outer shell. It's akin to a giant mortar and pestle. Then, more specialized than jaw crushers, cone crushers are used for secondary or tertiary crushing. They provide a more refined breakdown by squeezing the rock between an eccentrically gyrating spindle and a concave hopper. Once the initial crushing has been accomplished, it's time to move on to grinding. Here, the goal is to reduce the crushed material even further until it transforms into fine particles.
So, nice. Not a bad little day. And I don't know what we got left in those other mats. That'll be interesting to see if you clean them up separate.
A cylindrical device known as a ball mill is filled with steel balls and rotates around a horizontal axis. As they turn, the balls fall back onto the material, grinding it into a fine powder. Ball mills are highly efficient for both primary and secondary grinding stages. Thereafter, a semi-autogenous grinding mill is employed, utilizing both grinding balls and the material itself for grinding purposes. SAG mills can handle larger quantities, but require more energy. Similar in function to ball mills, but uses long rods instead of balls, is the rod mills. These are typically employed for ores that need finer grinding. This transitions us into the next step, which is reducing the ore size. Reducing ore size is not just about making it smaller.
A small line on our middlings or our beacons.
Sure, coming underneath.
It's about increasing surface area. When the ore is finely ground, a greater surface area allows chemicals used in subsequent extraction processes, like cyanidation, to interact more effectively with gold particles. Fine particles ensure that gold can be liberated from other minerals more easily during concentration methods such as gravity separation or flotation. After that, optimal leaching is employed because smaller particles improve leaching efficiency by allowing better penetration of leaching agents. Now on to how these fine powders undergo further treatment to isolate their golden content entirely, unlocking their true value. Imagine holding a lump of rock in your hand, knowing that tiny flecks of gold are hidden within its dense core. To unlock this treasure, we must first transform the crushed ore into a fine powder. This critical stage, often referred to as grinding, is where raw potential begins to shape into tangible wealth. The journey from coarse gravel to fine dust begins with grinding mills. These robust machines take the already crushed ore and pulverize it further until it achieves a powdery consistency. Initially, the ore is fed into large rotating cylinders filled with heavy steel balls or rods. As the cylinder spins, the impact and abrasion from these balls crush the ore into finer particles. This is known as primary grinding. Secondary mining follows immediately.
10 specks of gold and I will be very happy.
Yeah, and this is you've high-graded some stuff out of the vein?
Which involves a milling technique to achieve an even finer grind. Ensuring consistency isn't just about hitting a target size. It's about precision and efficiency in every subsequent step. Imagine trying to pan for gold with gravel instead of silt. That's how important this stage is. Grinding crushed ore into powder sets the stage for extracting those shimmering particles hidden deep within the rock. Each spin of a mill drum brings us closer to unlocking nature's concealed treasures, preparing our precious material for its next transformative phase of becoming pure gold. The extraction process. When you have a mountain of powdered gold ore, it's time to concentrate that gold from the powdered ore. This stage is like turning raw ingredients into a delicious dish, requiring precision and skill. Gold concentration is about separating the precious metal from other minerals. It's like panning for gold, but on a larger scale. The goal is to increase the amount of gold in the material we'll work with next. Gravity separation follows immediately. This relies on the difference in density between gold and other materials. Gold, being denser, naturally sinks while lighter materials float away. This method often involves shaking tables, where a table shakes back and forth, causing heavier gold particles to move differently than lighter ones. Thereafter, they are moved to the spiral concentrators. These are spiral-shaped devices where ore slurry is fed to the top and flows down, with heavier gold particles moving toward the center, and from here they are made ready for the jigs. Think of these jigs as sieves that pulsate water through them, helping separate heavy gold from lighter waste. Then flotation is followed, which is an intriguing process where bubbles do all the heavy lifting, literally. Here's how it works. Ore slurry is mixed with chemicals called flotation reagents. Air is pumped through the slurry, creating bubbles. Gold particles attach to these bubbles and float to the surface, forming a frothy layer. The froth is skimmed off, leaving behind less valuable minerals. This method is particularly effective for ores that contain sulfides or other minerals that respond well to flotation reagents. It doesn't stop here, as amalgamation comes into play next. This method has been used since ancient times and involves mercury's unique ability to bond with gold. Here's what happens. Mercury is mixed with powdered ore. Gold bonds with mercury to form an amalgam. The amalgam is separated from other materials. The amalgam is heated, vaporizing mercury, which is collected and leaving behind pure gold. While this method can be quite efficient, it's falling out of favor due to environmental concerns associated with mercury use. Now, what is the bigger picture? Each concentration method has its unique charm and utility, depending on the type of ore being processed and environmental considerations. By leveraging gravity separation's simplicity, flotation's finesse, or amalgamation's historical prowess, miners can isolate gold from other minerals effectively.
How would you like to own a gold mine? Yeah? Turns out you really can.
I would love to own a gold mine.
This orchestration of methods ensures that when we move forward in our journey from ore to gold bar, we're working with material that's rich in potential, ready for its next transformation stage. Chemical extraction, cyanidation. Ever wondered how we go from gold ore to near pure gold bars? The answer lies in the fascinating process known as cyanidation. In this process, cyanide dissolves gold from its ore, making it accessible for extraction. Let's explore deeper into this captivating dance. Cyanidation is essentially a hydrometallurgical technique where cyanide solutions are used to extract precious metals like gold and silver from their ores. Here's how this intricate process works. The ore is first ground into a fine powder, creating a larger surface area for the cyanide to act upon. This powdered ore is then mixed with water and a solution of sodium cyanide or potassium cyanide. Under alkaline conditions, typically maintained by adding lime, the cyanide dissolves gold and other metals in the ore. Activated carbon or zinc powder is introduced to absorb or precipitate the dissolved gold, separating it from the solution. Finally, the collected gold undergoes further refining processes to reach high purity levels. This method has transformed modern mining operations by significantly enhancing gold recovery rates compared to older methods. What is the role of cyanide in extraction? Cyanide's role in extracting gold is both crucial and interesting. When cyanide is mixed with the finely ground ore, it forms a soluble complex with gold, known as gold cyanide complex. Essentially, oxygen acts as a catalyst, while water facilitates the reaction. The result? Gold transitions from the solid form in the ore to a soluble state in the solution, making it easier to separate and collect. This process is not without its environmental concerns. With great power comes great responsibility, or in this case, great environmental concerns. Cyanide is highly toxic, not just to humans, but also to wildlife and aquatic ecosystems. However, advancements in technology and stringent regulations ensure its safe usage. Modern facilities use impermeable liners and containment systems to prevent leaks into soil or groundwater. Waste solutions undergo detoxification processes, such as INCO treatment, that neutralizes cyanide before discharge. Continuous monitoring systems are employed to detect any potential leaks or breaches early on. Safety measures extend beyond environmental precautions. Mining personnel receive rigorous training on handling cyanide safely. However, one may ask, aren't there alternatives? While cyanidation remains dominant, alternative methods like the carbon-in-pulp process offer valuable insights. In this method, activated carbon particles are added directly into the leach tanks, where they absorb dissolved gold from the slurry. This eliminates steps involved in conventional cyanidation processes and enhances efficiency. Also, a promising alternative that uses thiosulfate as a leaching agent instead of cyanide is available. It's more environmentally friendly, but still under extensive research for commercial viability. From its role in extracting precious metals to potential environmental impacts and alternative innovations, cyanidation remains an integral part of our journey toward creating 99% pure gold bars. Smelting and refining. Smelting is the process of transforming gold concentrate into pure, shiny bullion. Think of it as a high-stakes cooking show, where the ingredients are precious metals and the kitchen tools are industrial furnaces. Smelting involves heating the gold concentrate to a temperature where the metal melts and separates from its ore. Typically, this occurs in a furnace that can reach temperatures upwards of 1,200 degrees Celsius. The heat essentially breaks down the chemical bonds in the ore, freeing the gold from other minerals. Fluxes comes into play next. In this fiery process, fluxes, substances like silica or borax, are added to the mix. These materials might not get much spotlight, but their role is indispensable. Fluxes help by combining with impurities to form a slag. This slag floats on top of the molten gold and can be easily removed. Without fluxes, separating gold from its less desirable companions would be akin to untangling spaghetti with one hand. Now for the grand finale. Pouring that molten gold into molds. Picture liquid gold cascading like a glowing waterfall into specially designed molds. These molds determine the shape and size of what will become bullion bars. As the molten metal cools and solidifies, it takes on that iconic rectangular form we associate with treasure chests and bank vaults. Each mold must meet stringent specifications to ensure uniformity in weight and dimensions. Precision here isn't just about aesthetics. It's crucial for market standards and future transactions. Once cooled, these newly formed bars are ready for further refining or direct sale depending on their purity level. Ever wondered how gold transforms from its raw, glittering state to the gleaming bars of near-perfect purity? Here's where the magic happens: refining. The aim is to achieve a dazzling 99% purity, and it involves some interesting chemistry and intricate methods. The Miller process is one of the oldest and simplest methods used for refining gold. It's like a well-choreographed dance, where molten gold takes center stage. Here's how it works. Chlorine gas is introduced to the molten gold, and chlorine reacts with impurities. Impurities such as silver, copper, and iron form chlorides that separate from the gold. These chlorides float to the surface and are skimmed off, leaving behind purer gold. This method is quick and effective, typically achieving a purity of about 99.5%. However, it's not perfect for achieving the ultimate purity levels necessary for certain high-end applications. Now for those seeking near absolute purity, enter the Wohlwill process. This method employs electrolysis. Think of it as a scientific spa treatment for gold. Here, gold chloride is dissolved in hydrochloric acid. Using an electric current, pure gold plates out onto a cathode, while impurities remain in solution or form sludge at the bottom. This process can achieve an astoundingly high purity level of up to 99.999%. By ensuring that impurities are meticulously removed, this process caters particularly to industries requiring exceptionally pure gold, such as electronics and medical fields. Why does purity matter? Achieving 99.9% purity is crucial for various practical reasons such as commercial value. Higher purity means higher market value. Investors and traders prize ultra-pure gold for its stability and reliability. Industries like electronics depend on high-purity gold for components due to its excellent conductivity and resistance to tarnish. In jewelry, making pure gold provides the unmatched luster and malleability essential for crafting intricate designs. Refining may seem like an elaborate application with elements and electric currents, but it's this meticulous process that ensures gold reaches its highest potential, ready to shine in all its glory across various applications worldwide. Have you ever wondered how those shiny gold bars are made? Let's explore the fascinating process of shaping gold bars, where precision meets artistry. Melting and pouring. First, the refined gold, now free from impurities, is melted in high-temperature furnaces. The molten gold reaches temperatures exceeding 1064 degrees Celsius. This intense heat ensures that the gold becomes a liquid, ready to be crafted into bars. Once liquefied, the gold is carefully poured into molds. These molds are typically made of graphite or cast iron, materials that can withstand extreme temperatures without reacting with the molten metal. The shapes and sizes of these molds vary depending on the desired specifications of the bars. Precision pouring is crucial. Any misstep here could lead to imperfections or inconsistencies in weight. Creating gold bars isn't just about melting and pouring. It's a meticulous process that demands an exceptional level of accuracy. Each bar must meet stringent criteria for weight and dimensions. For example, standard gold bars typically weigh 400 troy ounces, approximately 12.4 kilograms, but smaller denominations like 1 kilogram bars are also common. The length, width, and thickness of each bar need to conform to specific standards to ensure uniformity.
100 gram, 500 grams. This is according to...
To achieve this precision, advanced measuring instruments and techniques are employed. Skilled artisans oversee this process, ensuring that every bar produced meets the highest standards of quality. After being poured into molds, the molten gold begins its cooling process. Rapid cooling can cause stress fractures or other defects, so this stage must be carefully controlled. The molds are allowed to cool in a controlled environment until the gold solidifies completely. Once cooled, each bar undergoes a rigorous inspection process, including experts checking for any visible imperfections or irregularities. Each bar is weighed to ensure it meets the specified requirements. Precise measurements are taken to verify that the bar's dimensions are within acceptable limits. These inspections guarantee that only flawless bars make it through to their next stage. This stage involves stamping and serializing. Here, you can feel that the whole process is gradually winding down. Imagine holding a gold bar in your hand. It's heavy, shiny, and undeniably precious. But what makes it truly unique and valuable isn't just its pure gold content. It's the stamps and serial numbers that tell its story. Stamping gold bars is a conscientious process that ensures each bar carries essential information about its identity. After the cooling process, gold bars are moved to a stamping station where they're embossed with crucial details like weight. Each bar is stamped with its exact weight, often in troy ounces. The fineness of the gold is usually displayed as a percentage of 99.99%. Thereafter, serial numbers are enshrined in the gold bar. This is a unique identifier that distinguishes one bar from another. Specialized machinery is used to stamp these details onto the surface of the gold. This machinery needs to apply enough pressure to create clear, legible markings without damaging the bar's integrity. So, why bother with all this stamping and serializing? These markings serve several important purposes. Stamps guarantee that the bar has been verified by a reputable source. They act as a certificate of authenticity. Serial numbers make it possible to trace each bar from the refinery to its current owner. This transparency is vital for preventing fraud and maintaining market trust. Also, knowing the weight and purity at a glance allows for quick valuation, which is essential for trading and investment purposes. A gold bar without these markings would be like a painting without an artist's signature, valuable but lacking provenance. Now to the final step, polishing and packaging. Once stamped, many gold bars go through additional steps to enhance their presentation. Bars are often polished to enhance their sheen, making them more visually appealing. Finally, bars may be sealed in tamper-evident packaging. This packaging protects against damage and further ensures authenticity by showing if the bar has been tampered with. These steps might seem excessive, but they add layers of security and trustworthiness to each piece of this precious metal. Holding a stamped and serialized gold bar feels like holding a piece of history, a tangible asset that has been meticulously crafted, authenticated, and preserved for the future. Thanks for watching. See you in the next one.